To calculate the phase converter size for your application, there are two load conditions we need to consider. The first load condition is the largest starting or running load. And the second condition is the total running load, which is the sum of all the machines that you want to run at the same time. The process for doing this is to first find the horsepower ratings of the main spindle of all your machines. Next, you need to find the multiplier for each machine within our load tables and multiply your horsepower of the main spindle times that multiplier, and you'll get a resultant number. Next, you'll take all of the machines that you want to run at any given time and you'll add all of those resultant numbers together. Next, you will compare the sum of all of the machines that you want to run together to the largest single machine starting load, and you'll take the largest value. For resistive and inductive loads, you will need to see our sizing document to get the proper size phase converter for the amp rating of your machine. Some examples of machines that fit into this load category are ovens, welders, plasma cutters, kilns, battery chargers, and wire EDMs. Here are some examples of light, medium, and heavy loads. For light loads, we use a 1x multiplier. Some machines that fit into this load category are Bridgeport mills, drill presses, bandsaws, power feed and conveyors, joiners, overhead hoist, small belt and disc sanders, and tire balancers. For medium loads, we use a 1.5 times multiplier, and some machines that fit into this category are lathes, table saws, surface grinders, planers, molders, fans and exhaust, radial arm saws, chop saws, shapers, and pretty much anything that has a speed increaser or a high speed motor on it, or pulley or gear speed increasers. For heavy loads, we use a 2x multiplier, and if you're in doubt, this 2x load condition is always the safe bet. Some machines that fit in this heavy load category are HVAC, CNC equipment, air compressors, hydraulic and water pumps, vacuum pumps, dust collection, wide belt sanders, hydraulic automotive lifts, iron workers, meat grinders, mixers, grain augers, grain dryers, and any system that has high constant loads. I'd like to take you through two examples of the different types of conditions. The first example I'm going to go through, we're going to want to run multiple machines at the same time. Let's consider we're a woodworker and have a table saw, dust collector, wide belt sander, and a joiner. For the table saw is 3 horsepower, the dust collector is 5 horsepower, the wide belt sander is 10 horsepower, and the joiner is 1 horsepower. We're going to go through and find the multipliers within the table that we need to use for each of these machines, which is a 1.5 times multiplier for the table saw, a 2x multiplier for the dust collector, a 2x multiplier for the wide belt sander, and a 1x multiplier for the joiner. So for the table saw, we would get a resultant need of 4.5 horsepower. For the dust collector, we need 10 horsepower. For the wide belt sander, we would need 20 horsepower, and the joiner would need 1 horsepower. Now, we would want to run the dust collector at the same time as all of these machines. We're going to consider that we're only a one-person shop, so we're going to use the dust collector with the largest machine. So the largest machine that we run with the dust collector is the wide belt sander, which has a need of 20 horsepower. So to calculate the converter size that we would need, we would add the 20 horsepower need of the belt sander and the 10 horsepower need of the dust collector together, and we would get a resultant of 30 horsepower. Being all of the other machines are smaller than the wide belt sander, we would be able to run any of those other machines at the same time with the dust collector and have extra capability left over. So 30 horsepower would be the size that you would want to go with. The second example that I want to go through is a situation where we have one machine that is larger than the rest that drives the need for the size of the phase converter. So let's consider we're a fab shop and we have a 15 horse hydraulic press brake, a 5 horse horizontal bandsaw, a 1.5 horsepower Bridgeport mill, and a 5 horsepower lathe. Now we will look at all of the multipliers for each machine. For the hydraulic press brake, we'll need a 2x multiplier. For the bandsaw, we'll need a 1x multiplier. The Bridgeport mill will be a 1x multiplier. And the lathe will be a 1.5x multiplier. So the resultant need is 30 horsepower for the hydraulic press brake, 5 horsepower for the bandsaw, 1.5 horsepower for the Bridgeport mill, and 7.5 horsepower for the lathe. We're a one-man shop, so we're just going to run one machine at a time. Looking at the resultant need for converter size, the hydraulic press brake drives the size with a 30 horsepower need.